So we looked a little bit about adding vectors, but only if they were position vectors. But you can add and subtract any vectors. So according to this, u is a vector that goes 5 to the right. And v is a vector that goes 4 to the right and then 5 up. If you wanted to put them together, all you have to do is take your vector v, oh, it's stuck there, and add it on to your vector u. So you go in your u direction first, and then you go your v direction afterwards. So there you have the vector u plus v. We always join our vectors head to tail. So vector u is going in this direction. This would be the head of that vector. And vector v is going in this direction. That would be the head of that vector. And so when we join them together, we take the tail of vector v and join it to the head of vector u. The order doesn't matter. So u plus v is the same as going v plus u. Just like our convenience store question before, you end up at the same place. What's different is the route that your stopping place along the way is going to be at a different spot. But with vectors, that doesn't matter because you're really concerned about where did you start and where did you end. And u plus v and v plus u both start at the same place and end at the same place. So in this case, if we added them together, because our vector u was 4, 5, my vector v was 4, 5, and u was 5, 0, again, the column vector is really easy to see the math, but you could write it with your unit vectors as well. So here's our resultant vector, 9, 5, and like we showed before, you could just simply add up those column vectors and add up the corresponding components. Same concepts with subtracting. If you go u minus v, that's like going in the u direction, and then the minus v is the opposite direction that v was. So here, we had 5, 0 as u, minus 4, 5, and again, you're just subtracting the components. And you get 1, negative 5. And this works in 2 dimensions, just like it works with 3 dimensions. And if you wanted to do 4 dimensions or 5 dimensions, you could do that as well. It's just harder to visualize what's happening. What's that? Yes, in this case it matters, just like in math if you were subtracting, right? If you're adding, 9 plus 3 is equal to 3 plus 9. But 9 minus 3 is not equal to 3 minus 9. Because one would be negative and one would be positive. So u minus v isn't the same as v minus u. Which one you start with depends on what the question is asking for. So in this case, if I wanted to start at u, and then go backwards to v, and that was what I wanted to do as a result, I could have done minus v first and then plus u. That would be okay, if you're wondering about that. But this example is just looking at what u minus v looks like. Yeah, the question will say that. So for example, if A is this and B is that, draw them and draw A plus B and draw B minus A and 2B plus 2A. So there's some drawings for you to check. And there are the answers as column vectors as well. So for example, in the first one, A plus B, A is 2I minus j, so it's 2 in the x direction minus 1 in the y direction. So this blue vector here is our vector A. Then if once we get to the end of A, B is minus 1 in the x direction, 3 up. So this green vector is the vector B. And if you started from A and went to B, you would be going 1 over and 2 up. Now that's showing you drawing all the vectors. What are you eventually going to do in questions like this? Well, you're going to say, I know that vector A is 2, negative 1. And I know that vector B is negative 1, 3. And if I add those components together, I'm going to get 1, 2. And see that as my resultant vector. And you probably have, for those of you that take physics, you've seen this kind of idea in physics, right? When you have something pushing on an object in one direction, something pushing on an object in another direction, what direction does that object end up going or moving? Or what is the resultant force on that object? Well, that's just putting vectors together. So here we're not going to draw them. All we're going to do is the math surrounded with them. And I'll put the answers up in a bit. If you want to check how you're doing. Check how you did on the next one. So again, a picture is nice. You can say, well, A to B, B to C is that. Finding A to C, well, that's just A to B plus B to C. So it's a little different because you're given A to B and A to C. So when you're putting them together, one of them is going to have to be a negative vector because you're going to have to go back from B to A and then from A to C. Again, the picture really helps you see that. Finally, the 0 vector. If you go around in a triangle, if you start at P, go all the way around and end at P, you will end up not moving at all. Well, you'll have moved, but you will not have changed any place. Runners like the 0 vector. They go out for a jog. They start at one spot. They run around, they end at the same spot. I'm not a runner because I'm like, I could get to that spot a lot quicker if I didn't go anywhere. I don't know if that's good for my overall health, but mathematically I get a lot more done. Except I don't get the running in. So when you write the 0 vector, this is a 0 that's bolded. That's a 0 vector. If you're writing it, you can write 0 with a vector over top of it. For homework, you have to write out what the 0 vector looks like in all the dimensions after 3. No, just kidding. You might recognize a pattern.